input to another neuron. So this one unit is called neuron. So we have to pass this information to another so-called neuron to continue process the information, generate the output, pass into the another neurons, and continue. So inside your brain, there are actually millions of neurons inside the brain. So it's used to process the information. So researchers get these ideas and then develop artificial neural networks. It's not like the same where we have input neurons, right? So we have these all neurons here, okay, to process the input. Okay, so you can imagine that we have an input, or we call it as a features. We pass into the neuron to process so that we can generate the output. So this is the output. Let's see. So it's about the same, the ideas. So whenever you will see across, like you come across with these architectures together with this. So how do we come up with this artificial neural network? It's actually come from the biological neural network. So I will explain in more details how the calculation take place in the artificial neural network in chapter 9. Okay, so yeah, that's not very important. So that's machine things like rationally. So as I mentioned, whenever you say rationally, it's referred to logically. So when I say logically, then it's actually supported by the rule base, if L rules. So one of the famous application would be the expert system. Okay, think rationally. Okay, so act rationally is actually a branch where machine or a system is able to act autonomously, okay, and then sense to the environment, and then send back to the system to check the rule base and adapt to the change. Let's say if you still aware the Tesla car, the autopilot mode. What is autopilot? Autopilot is what? It is a mode where you do not need human intervention, right? So the car will move by itself. Okay, do you notice there's a Tesla car in our campus? Yes, in the block. I think he parked at the block D. Block D or block B. Block D, I think. There's one Tesla car, the white color one. Yeah, very rich, but I don't know who is the lecturer. Okay, so imagine that we have a Tesla car here. So you will notice that there are a lot of sensors, whether it's the cameras, a lot of sensors hidden inside this Tesla car. So this Tesla car will actually move and then sense around environment. We always sense to the environment, okay? Every single moment, sense to the environment. Let's say we have a traffic light here, okay? Let's say it's a red light. So this Tesla car will actually sense to the right and send back to the rule base. Why rule base? Because it is a system act rationally, supported by the rule base. So if the traffic light is equal to red, then what happens? So we have all the rules here. So whenever this is a red light, so it will trigger these rules. Then we will act accordingly, which is so-called adapt to the change. So initially you are moving, so you sense it, you send it back. So you have to reduce the speed. So adapt to the change. You have to change the situations, and finally pursue the goal. So if you want to stop before the traffic lights. So that's your goal. Okay. So remember always. Whenever you have a rational, it means logically. So whenever you logically, it means support by the rule base. Okay, yeah, come to the last sections of this first chapters. Yeah, last section already, don't worry. So we have two very important concepts in AI. The first one known as Turing test. The second one known as Chinese room. So what is Turing test? Turing test is actually developed by this fellow, it's called Alan Turing, in 1950. So in one of his research paper, Computing Machinery and Intelligence, so he asked, can machine think? How do machines behave like the humans, and how do we conclude that machines is considered smart or intelligent? So we can actually this Alan Turing has actually come up with a test, yeah, saying that, okay, as long as the machine is able to behave or able to communicate like a human to the humans, then we can actually say this machine is smart enough. So he came up with a test. He designed a test where we have 3 rooms here. Okay. Okay, so we have 3 rooms. So the first room, I would say room A, we have a room B, we have a room C. So room A is a interrogator. Or we call it as an evaluator. Or sometimes it's interviewer. Right? So what is the purpose of evaluator or interrogator is to ask questions. Right? So this interrogator will ask questions to these 2 parties. Okay, so who is inside these 2 parties here? So we have 2 parties formed by, one is humans, another one is the computers. Or that time maybe you can call it as a chatbot. One is a chatbot, one is the humans, and randomly placed. So let's say this is a human. An interrogator doesn't know which one is human and computer doesn't know. He got no idea, so he has to find out. So we have a chatbot or PC here. So this interrogator will ask questions. Maybe max question, 2 plus 2 equal to what? So then this PC will respond, right? Human as well will respond. So this human will try to convince this interrogator that he or she is a human. Meanwhile, this computer is trying to deceive this it is a human also. So this is their role, right? So this human try to convince that it is he or she is a human, and meanwhile the computer try to deceive that it is a human also. Then let the interrogator to decide which one is human. If let's say the interrogator says that room A or room B, room B is computer, then we will say that this PC or the chatbot failed the Turing test. Not smart enough to deceive the interrogator that it is a human. Okay, if it says that C is a PC, then we say that the PC passed Turing test, because the PC is very smart, is able to behave like a human. Check with the interrogator, make the interrogator feel that I'm talking to a human. Okay, so that is the ideas of the Turing test. Do you get it? Yeah. So what is Turing test? Imitation game. Okay. Yeah. So it's also known as an imitation game, right? So there's one movie, Turing test, Alan Turing. You can actually watch it. So yeah, that is the ideas of the Turing imitation games. Alan Turing says that as long as the PC or the chatbot is able to communicate like a human, then we can say that it passed the Turing test. It is smart enough. And then this is some of the examples of the Turing test. Not the examples, but somehow, if you are able to build applications that to solve the CAPTCHA, then I would say that your application passed the Turing test. Do you still remember what is Turing test? To deceive the human that it has the ability, right? So if you are able to build an application to solve this CAPTCHA, nowadays we still need human, right, to select all the pictures. But if you are able to build an application to auto-detect, to solve this CAPTCHA, then your applications considers smart enough, pass the Turing test. But so far, none of the researchers managed to build the algorithms. If you managed to build it for your assignment, for your FYP, you can send it for the competitions. It's not easy. It's not easy to solve the CAPTCHA. Okay, so we have a Loebner prize here. It's not very important. It's just a competitions where we use a Turing test to see which machines having the ability to deceive the interrogators. Who has the most so-called human-like machine then can win the prize, which is the gold medals. Yeah, let's move on to the last ideas, a concept called Chinese room. So I will play this video, try to see whether you understand these ideas or not, right? Just a 1 minute video.
60-second adventures in thought. Number 3, the Chinese room. Can a machine ever be truly called intelligent? American philosopher and Rhodes Scholar John Searle certainly can. In 1980, he proposed the Chinese room thought experiment in order to challenge the concept of strong artificial intelligence, and not because of some 80s design fad. He imagines himself in a room with boxes of Chinese characters he can't understand and a book of instructions which he can. If a Chinese speaker outside the room passes him messages under the door, Searle can follow instructions from the book to select an appropriate response. The person on the other side would think they're chatting with a Chinese speaker, just one who doesn't get out much. But really, it's a confused philosopher. Now, according to Alan Turing, the father of computer science, if a computer program can convince a human they're communicating with another human, then it could be said to think. The Chinese room suggests that however well you program a computer, it doesn't understand Chinese, it only simulates that knowledge, which isn't really intelligence. But then sometimes humans aren't that intelligent either.
Okay, boleh faham? Boleh faham? Sure. Oh, anyone boleh faham? You? Can you faham? Can you understand this? You. Can you? Can? Tak boleh. You? Anyone? Is it too fast? I make it 0.25? No. Okay, so what Chinese says is, anyone doesn't know Chinese words? Anyone? You. Only you. You are? Banana. Okay. Oh, Milo. Always champion, huh? Okay, so what Chinese room say is developed by the John Searle. So it says that imagine that inside a room, okay, we put one Mat Salleh who doesn't know Chinese at all. You got no idea what is Chinese, never learned Chinese at all. Okay, what happened? So we will provide a lot of Chinese characters. Okay, this is Chinese characters. You don't know what? He doesn't know the meanings of all the letters. But at the same time, we give a book of instructions in English. Where this fella, this Mat Salleh, can understand. So we have all the rules here. If then. He can understand, but he cannot understand this characters. Imagine. So now what's the next? So now we have one Chinese speaker. So he tried to ask the questions inside the room. He thought that there's inside the room there's one fellow very good in Chinese. Then he asked questions. Let's say, okay, he fit inside. Okay, so assume that we have two rules here. Assume that in the instruction book, we have this. If okay, so assume that you have two rules. Banana. What is your name? Milo? Brian. Okay, assume that you are this Brian. Brian. BRI. Why so complicated? BRI. AN. Oh, okay, Brian. Where are you from?
Malaysia.
From here, Selapa. Singapore, Johor. KL. Oh, okay. So Brian, so assume that you're the Mat Salleh. So now we have this input. So which other people should okay? Which output do you think that you will feed back to this the user outside the room? Can't see it. You use the phone, zoom in. So you have two rules here. Which output should you, Brian's, send to the Chinese speaker? In text, we talk about the text. The first one, you will reply the first one. So other, is it correct? Why you choose number 1 instead of number 2? Because of same word, I would say same patterns, right? Same patterns, right? Kind of pattern. You're doing pattern recognitions, correct or not? So now my question is, can we say Brian smart? He can answer these questions, but he doesn't understand this meaning. He basically just doing pattern matching. Oh, same. Okay, I give the output. So can we conclude Brian smart? Yes or no? There's no wrong or right. So that is the Chinese room concept. Chinese room says that to conclude a machine to be intelligent, a machine should understand the input and output. But the Turing test, Alan Turing says that as long as you are able to communicate, doesn't matter you understand or not, you consider smart. But Chinese room disagree, criticize the limitations of the Turing test. He says that you cannot say, oh, machine is smart because it's just able to answer. Just like today you memorize all the theories in AIs. Memorize, you don't understand. You just memorize chapter 1 to chapter 13. You sit for the final examinations. You manage to answer all the questions correctly. You score 100 marks. Can I say you're smart? You score 100 marks. But you don't understand. You just memorize theory, you put an answer. Can I say you're smart? What your thought? Some say yes, some say no, right? So it depends on you. There's no wrong or right. It's just a concept, right? So always remember, Turing test says as long as you're able to communicate, you are smart. Chinese room say no, you should understand. Then only we can say it is smart. Otherwise, everybody also can consider as smart because you are basically just simulate the intelligence. You are not having the actual intelligence. So now are you clear? What is the difference between these two now? Okay, good. Anyone still blur? Okay, clear. Very good. So I'll give you one example. Maybe you are still cannot catch the pictures. I'll give you one example here. Okay, so look at this slide. So assume that you have this input WRE. So DRI is a HEN. So which rules do you think that it will generate by the chatbot? Assuming that this is chatbot, you have only 2 rules inside the chatbot. So which output that it will generate based on the input given? Number 1 or number 2? One or two? Two. Sure. Number 2 or all of 3, yeah? So correct. But do you understand the meanings of this? Do you understand the meaning of this? You don't understand. But you managed to give correct output. So if Chinese room, then you're not smart. If Turing test, yes, you fall under intelligence categories. Okay, so that is the idea. So let you to think there's no wrong, there's no right. So is it necessary to for the machine to understand the input and output? So it's up to you. Okay, so that's it for today. If you still have any query, any questions, you are not really sure, that you can scan this code. It's actually an Excel file for you to put in the questions. In case you shy to ask during the class, then you can put the questions. Every chapters. So it's not about anymore. It's just an Excel file. Okay. So if no questions, then I would like to stop the lessons, the first lessons here. I will see you next week. So next week we will cover the first AI applications, problem definition and problem solving. Okay.